Happy Bowtie Friday. I'm Austin Griffith hanging out with the Build Guild. Today we're looking at a payment channel built into scaffold-eth and a new deployment system. I think we're going to bring in HardHat deploy, and we're going to start tracking our deployments a lot better. Kind of in a previous version, we would deploy and those artifacts would be very ephemeral, and you would kind of like maybe drag them around if you wanted to, but they would be injected, and it was hard to understand. Like, I deployed to local, I deployed to Robston. Where are those artifacts? What have I done? So I think we're going to bring in WiggleWog's HardHat deploy, and I think Adam will do that, and I'll let Adam kick it off. Go ahead, Adam, to teach us the new ways of the deployment. And it's not on master yet either, right? Like, we're thinking about bringing it into master.
Yeah. So this, I guess, is the most exciting kind of thing, which is a refactor. But actually, like it is pretty cool because essentially it's prompted by so I was working with actually a couple of the folks here on like starting to do more L2 stuff. As soon as you start thinking about like multiple networks, like you're deploying contracts in one place, another place, and like scaffold-eth's like built-in deploy system was pretty much focused on like one network at a time. And so I think for Nifty Inc, we'd done some like dancing to kind of make it work, but we want to make it that sort of kind of work a bit more easily out the box, I guess. Can you let me share my screen, please?
Oh, you're good now. Sorry.
No worries. We'll go for the whole thing, the whole screen. Nice. Yeah. So so I guess the branch I'm on actually to push a bunch of stuff it's in chains and deployments right now, and they're like, I guess I'm talking about changes in two places. So firstly, there are a bunch of changes, and the real like business is in the HardHat package. But then there are also some sort of downstream changes that have kind of happened and will hopefully make life easier in the React app as well. So I guess I'll start with like the HardHat package. So don't know how familiar folks are with the sort of scripts up in here, but like previously, when you essentially deployed your contracts, so yarn deploy, it would run a script which is still here, this deploy script, which is essentially just like deploy your contract. And so you could obviously do like loads more stuff in there. Like in the script, we've got a load of sort of example stuff to kind of help you out. But that doesn't necessarily, well, it means you can end up like with these big monstrous like deploy scripts, and if you and the thing that would happen after deploying is that it kind of goes through this publish script, which would then like push these to the front end. What HardHat deploy is, it's a package, as Austin said, by WiggleWog's. I think I've got it here. It's a HardHat plugin, so it basically is for replicable deployments and easy testing. So what it does is it handles a load of that sort of persisting, like what you've deployed and where, makes it really easy to sort of push that into your front end. And so we can take a bunch of sort of scaffold-eth type custom code and like use a package. It's hopefully a bit neater, and he's always adding new features. So it's a really cool thing to plug in. So I guess the main difference, or like the first difference, is instead of this like deploy script being where the business happens, you've got this folder called deploy. And what this deploy folder does is it essentially, when you run this specific new function, so again, we've just wrapped into yarn deploy. If you then run HardHat deploy, it'll go to this folder, and it'll essentially run those like the files there in alphabetical order. So we've only got one in here at the moment, and so it will just run that one, but you could add like loads, and so it then becomes a bit more like a migration. So if you've got like a complex deployment with like multiple contracts, you could split them each into different files, have different logic, and so it just becomes a bit more like encapsulated. And then the other thing which is pretty neat is we've got this export all command, which basically says, okay, once you've done your deployment, export like everything to a certain place. And so essentially we're just pushing this all to our like HardHat contracts, like essentially pushing it into the front end. So that saves us having to have this like custom publish script. It's still there, more to put stuff into the subgraph place, but that's sort of the big change. So I've got everything hopefully running. I've got a local chain, I've got a deployer account, I've got the front end running. So then if we go here, and if I just run yarn deploy network, all right. Just see if it works first time. Let's see. So it compiles everything, pretty normal. and it pretty much just published it. So like the stuff that's kind of happened is pretty much exactly the same. You've got your like artifacts. The thing that is different is you've got your this and that like deployments folder, which is generated here. And it like identified that this was deployed into local, like deploying to localhost. And so like the cool thing here is that is like, and if we jump the front end, here we are, the usual thing, like DC, great, everything's kind of working. Yeah, so like that's all sort of like kind of working as intended, and that's pretty much like the vanilla like scaffold-eth setup. The cool thing here is that if I then say, okay, actually I want to do that again, and I want to deploy to Rinkeby, I've got nothing to compile because the contracts are exactly the same. I'll give it a second. It's deploying. Might take a little longer, maybe.
I totally want to I want to make his output look a little prettier too. I wish we could make it look just like a little, like add some color to it, just a little bit cleaner. And one other thing is the deployer account and the generate stuff the same? Do you still run yarn generate and yarn account?
Yes. So I'd still done yarn generate and yarn account. I guess the one thing, like if we jump into this, the other concept that it kind of introduces is this idea of named accounts. So essentially, like all I'm doing in this deployment file is I'm running this function here, where I effectively say, like, I'd like to deploy your contract. I'd like to deploy it from the deployer, which is an account I've named in the HardHat config. So like named accounts, and this basically says the deployer account is like the first account that we've got like on any given network. So this is one where if you have multiple accounts, maybe there was like a like an owner account or a like some other like types, it makes it a bit more sort of human readable than having to like manage addresses and that kind of thing. But yeah, you're still essentially using the same like mnemonic accounts that are generated by yarn generate.
Yeah, that's what okay, so there's kind of two different sets of accounts we should dive in. So when you do a yarn chain or a yarn node, you basically bring up the HardHat node. There are accounts there, and there's like a 0 account there, and it usually uses that 0 account to deploy locally. But then when you go to Rinkeby, there aren't those deployment accounts anymore, and you have to do a yarn generate to create a local mnemonic, and then it uses that mnemonic. Is that so? So when I saw the 0 account there in your settings, it looks like you're using the 0 account of the yarn chain, but really I think something else is going on in the back end to bring the mnemonic in as the first account. Is that right, or am I thinking about it right?
Yeah, that's right. So effectively here, where you've got like per network, you've got the accounts. If I jump to the like default, maybe this will, man, there's default a lot in this place. Yeah, so here we go. So like named account deployer, like this will take the first account as deployer. So like on the local host, will obviously take that first one, whereas on the like on these ones where they've only got this first account, but it'll take that one, if that makes sense.
Perfect. Yeah. Okay. So basically it's using the same thing that we already had, where we kind of hijack those accounts and add in a mnemonic for any public deployment. That's already a 0 account. This is kind of a layer up that's using that though. But basically all that stuff is the same. So far, really the only change you need to make so far is just that deploy folder. But I bet there'll be more. I'll be quiet.
Oh, no, so that's then the cool stuff. So now, like we've deployed to localhost and we deployed to Rinkeby. So that means that now actually in this deployments folder, where previously we were just like persisting the like latest deployed address, like here you can see we've got the localhost deployment, which has got this like your contract, and you've got the Rinkeby one as well. And what's cool there is that if we then jump into the front end, we are using like, so essentially slightly refactored the contract loader to be able to pull things in based on chain ID, so that like the structure of that like of the stuff that's pushed to contracts has changed. But if we've got this like HardHat contracts.json, this now has it segregated by chain ID, which means that like currently we're pointed at localhost. If we look at the front end, if you see that, so yeah, so currently we're pointed at localhost. Whereas if we jump back here and if we go and look at if we instead look at where do we deploy Rinkeby?
Oh, this is dope. So by selecting the target network in the front end, it's going to pick out the artifacts that go along with that network.
Yeah, so now I'm going to say this is Rinkeby. Great. Oh, yeah, okay. Having a bad time.
Wow. So your dev process, you're deploying locally and you're deploying to a test net. And just by switching your default network and your target network, you can just like kind of just select which ones you want to use, and it's going to use the latest one deployed on that network. That's awesome.
Yeah, pretty much. I think this is just, oh, it's because I'm not on.
Does this mean that when you deploy the contract, it gets deployed to all networks, where you select them to which one you want to deploy to, or?
Yeah, so that's the one which, so that's effectively controlled by the network hash. So you can name this here. So yarn deploy, and you could also change that if you jump into the HardHat config. You could also change that by changing the default network here, which I think is
okay. So you pass flag, and that's the network.
Yeah, pretty much. Okay. Like we could do the same thing with Govan, and that would deploy again. And like I've just pre-funded the deploy account on all these networks.
Cool.
So that then means that, yeah, and that then when you're in the front end, when you jump between these different networks, it then knows to look at the different places. So yeah, if we look at Rinkeby, that's one. But if we go back to localhost, where previously that would have been like overwritten and we'd never see again, we've still got this like original case. So if we say here, this is local. Now if I switch back here and I make this Rinkeby, and actually I'm not going to have any ETH, but yeah, like you get the idea. That's like essentially it just makes it easier to switch between networks. And then so, like another kind of cool thing is like let's say that you wanted to like deploy another contract with like a different name. So now if we like duplicate this guy, so deploy my contract JS. The thing here is I could say my contract, and I could and the thing here is you say so what we're saying here is that like I want to
and these are optional things that you're adding to kind of namespace the contract, right?
Yeah, so now if we pull and go there, now if I do, and let's go back to localhost.
A good example of this is I have a simple stream contract and I deploy the same exact simple stream contract for everyone's ETH stream. And it would be nice to be able to say, this is Adam's stream and this is Soren's stream, and be able to, select those contracts. And you could do that with this namespacing scheme.
Yeah, and now when I jump here and look at the HardHat contracts, like you can see if let's fold him away. So now we've got these two, like these ones which are all like deployed to localhost. You've got your contract here, and then you've got my contract there as well. So like again, it's just like easy management. And again, if I switch back to like another chain, I'd only have the contracts that were like deployed on that chain.
So what happens when you deploy over the top of the local host? Like, let's just say we do local host over and over and over again. Does it just replace it? Or does it like keep, okay. And then saying that, what happens if I deploy over and over again on mainnet? Does it also replace it? Or would I need to basically set up this naming scheme if I wanted to start keeping track of every one I deployed?
So I think, yeah, you would need to keep the naming scheme up. Like I think there is one thing which I haven't really fully dug into, where like you can essentially just get a proxy out of the box, where like effectively you just deploy once and then you just keep deploying proxies. And so like and that's a pattern that is sort of out of the box for HardHat deploy, where again there you don't even need to refresh the front end. That like it would just be like a change kind of on the fly in terms of what contract it was referring to.
I just thought of one thing that's totally a pain in the butt, and that's verifying on Etherscan. Something tells me that somewhere in here there's like some Etherscan magic that auto verifies or something.
Yeah, so I haven't got that set up, but there's like a HardHat. It essentially adds the Etherscan verify task to HardHat. So let's see, maybe if we go to here.
And basically we'll build this in eventually, but you'll probably do something like yarn verify and it will call this and go verify it. Cool.
So again, yeah, let's not go down.
Right. Another time. Right. For 2 Fridays, 2 weeks from now, we'll do that.
Yeah, and I guess the last thing, and like conscious of time, because it's just like all refactor talk. Like the other thing that has changes quite a lot is the contract loader quite a bit. So essentially, like as well as like refactoring it to just look at this new like data structure and expect a new data structure from HardHat. It's also if we pull it in here, the thing that's added here is so it goes and it looks at this like HardHat contracts file and it iterates through them and like creates a contract for each one, but it also looks for this like external contracts object in the same folder, and this is that thing where like I kept finding myself like instantiating ethers contracts like an ERC20 here or whatever like every time, whereas like obviously there's like a kind of structure for these. So again, this is like I think it'd be great to get sort of people's feedback on this, but like an easy way to essentially just provide addresses and ABIs and then get like contracts. So if we jump back to the front end, like if we look, it's basically powered. Like the other thing is that contractLoader is now powered by by one of two things: either the chain ID you set in the config, or the like network that a provider or signer is pointed at. So if you're like, if we look here, if we go to mainnet, for example, or maybe go just make the app point at mainnet in general, is that if we then look at the like read contracts, like you can see that if we go back to here, like we didn't have any HardHat contracts that were pointed at mainnet, but we have one in this like external contracts file. So basically it's keyed off the chain ID here, and it's got this die, like essentially the die ABI and the die address. And so if we like look in here, you can see that we've got in write contracts because I've connected to mainnet. That's what it's kind of seeing here. The thing here is that like basically making it really easy, saying if you wanted to then interact with like Uniswap, it's just then a matter of like forwarding here. And yeah, so now you can see write contracts is now, you can also just like interact with Uniswap just by changing that, like that one parameter. And the other thing that this I think kind of sets you up to do is to like rather than just relying on like always like putting this in the right place, and like, and I think this is the thing, I don't know if Calvin's not on, is he trying to extract the hooks? But like I think the like, because we want to make the contract loader like more generally useful rather than just specifically in scaffold-eth, but essentially being able to pass like any just like JSON, which has got the information you need, and it just returns like an array of contracts that you can then interact with. So yeah, again, it's a bit of a refactor, but hopefully gives folks more flexibility, so they're not like having to instantiate contracts like on the fly and ad hoc here and there. And that's
perfect. So thinking through the mental model changes, if you're already into scaffold-eth, your deploy files will change. You'll go to you'll go to that deploy folder and you'll do it there. Yeah. And then once it does deploy, you're going to have kind of namespaced, keyed off of the chain ID. You're going to have those contracts and artifacts stored more permanently. Does that add into GitHub, by the way? Do they get committed to GitHub, or are those hidden?
No, so okay. At the moment they're not committed to GitHub. There's one little thing where React, like, it has a bad time if the file isn't there. So there's a little helper that creates an empty file if you haven't deployed before you start up your front end. But yeah,
that's a good call. And then on the front end side, you've done some work with this external contracts file, where before, if you wanted to bring in the die contract, you would sort of edit the constants file and then bring it in, and then you would use an external contract reader. But the goal here is to kind of just have a contract reader that reads whether it's a local or whatever the artifacts are, and just use this external contracts versus HardHat contracts. Yeah, okay. Yeah. And HardHat contracts are sort of like one of the superpowers of scaffold-eth is be able to just sit down and iterate on a contract and see those changes and be able to deploy like 100 contracts, just being able to like try things out. But then once you have a contract that you like and you deploy it, you kind of need to track those artifacts. And that's kind of what you've done here, is just like a better artifact tracking. Well, you brought in Wigglewog's HardHat deploy, but
Yeah.
but still, like that's a lot of important work for scaffold-eth and taking care of quality of life stuff. So we appreciate it. And when are we going to merge that to master? Let's merge it. Let's do it.
Yeah, well, I'll do some kind of tidying up. Like if any folks have feel like the mental model doesn't kind of make sense, like that's really welcome, because obviously just here inside of my own brain. Yeah, as I say, all credit to WiggleWag. Like it's a really it's just so much easier when you're doing stuff across multiple networks, and we've got hopefully some cool stuff on arbitrum optimism coming up. And it just makes that development lifecycle much easier.
And they have HardHat Deploy has a Gitcoin grant that's live too. So go throw them $1 to signal toward them. Awesome.
Yes.
Next up is our payment channel guys, right? Viraz and Saddam have been working on kind of taking an old state channeling, payment channeling system and bring it into scaffold-eth. It helps with scalability. I feel like it unlocks some things. It kind of teaches you oh, shoot, we can just use signatures and do a lot of this off chain. So I'm excited to see what you guys have. Go ahead and take it away.
Yeah, I'll share my screen. Are you guys able to view?
Yep, we got it.
Yeah. So basically, I think the idea is it involves two parties, right? So for simplicity, right now we just taken a student and a teacher / mentor, right? So if suppose just taking a hypothetical example, that if I am a student and if I have I'm stuck on a coding problem, or I need any advice or suggestions, from a mentor / teacher, so I can just open up a payment channel with them, a time-based payment channel with them on on any Ethereum network, right? And then we can just start define how much amount and the duration that I want that channel to be live, right? And then what happens is we have a backend server which accepts signatures, right? And then every second it keeps accepting signatures, right, based on the time period that you set, and which is basically micropayments, right? So you'll see how much per 15 seconds, how much the teacher is getting paid, right? And then they have they have the power to withdraw, to claim and close the channel at any time. But the only thing is the channel has to be active. The time duration it needs to be there, right? It should not be zero. Like the time should not run out before that they should claim. Otherwise, the student has the option to get their state back that they put in. And yeah, every 15 seconds, so signatures are being sent. Yeah, I'll just show. Yeah, so basically
you kind of expect someone to drop off in a payment channel, right?
Yeah.
A lot of payment channels don't just end perfectly. They usually end with two people are kind of communicating, you're constantly signing things, and then someone drops off of one side, and then you just basically take the last signature and turn that in and get paid. Is that the right mental model there?
Yeah.
Cool.
Found a couple of bugs. I think I mentioned this while there were, as you said, there was quite a few test cases to test this with. So there were a few negative cases where a person drops off. Like say a teacher doesn't claim their a share of stake, right? So then the student should be able to get back their stake. So yeah, now it's working. I'll just show. Yeah, so this is so I've just put in the parameters, right? So this is the address I got from the incognito window, right? And I've set the channel to stream 0.1 ETH for 60 seconds and 60 seconds as duration, right? So once I do this, it will open up a channel, right? And then I'll define what. Just
so are you the student or the teacher right now? This 17.4C.
I'm the student. Let me. I think I'll have to reload. I had kept this running for an hour or so. I'll have to reload. I think I'm not sure. Yeah, I'm not sure it was working. Yeah, I'm just checking once.
As long as it's not a yarn fork, those ones time out quick. Yeah, this looks like it should be working. Let's see.
Yeah, it was. It's just I don't know. It's not a loading issue. I'll just get it up. Yeah.
So just to provide some more context while you're setting this up, basically there's this teacher-student scenario where the teacher is, in a very decentralized way, the teacher is helping the student out, and the student is constantly signing messages. Like maybe it's a tutorial session. As soon as the student like gets the information they need, they're just going to peace out and close everything up. The teacher is going to take the last signature and turn it in and get paid for that session. By the way, this is more like, think of this more like Spank Chain. Like there were a little bit different use case was using these more importantly and thinking like the OnlyFans kind of thing. Like there would be a performer and there would be some participants or some watchers, and they would all be streaming to the performer, and watchers could kind of drop off, and the performer would turn in those signatures. Okay, so here we go. So we are the student, and we're setting up a channel to the teacher. Is that right?
Yep. So it will just create one channel up. So now I can visit this as a student, right, and set the ETH stream per ETH. Like, sorry, the ETH amount that will stream out per ETH, right? So I'll just set 0.1, right, and I'll click on start streaming. So now you can see that this much ETH is being sent there every 15 seconds, right? And now when I visit this as the teacher, I will be able to see this, and then I will have the ability to withdraw, to claim and close the channel within this remaining 30 seconds, right? So if suppose I close this channel 10 seconds to go, so based on that, the amount, the 50-second amount I can claim, and the other one will be immediately transferred in the same transaction to the student back. So the remaining amount will be transferred in the same transaction. The student does not need to do any additional transactions to get the remaining state back.
Cool. Yeah. So you're saying when the teacher closes the channel, it releases the rest of the funds to the student. So the student will like over deposit. The student will say, I'm going to put $20 into this channel, and I may only end up streaming you $15 during the session. And when the teacher closes the session, it gives $15 to the teacher and $5 back to the student. That's cool. That's a good mechanism.
Yeah, so basically, I think as you see, a channel is being closed now. You see the status and all, right? So a student got some bit of amount, like 1 or 2 seconds worth of amount, right? And all the other amount was claimed by the teacher. And basically, your contract is, I think, pretty much 3 functions, right? Where you start off while opening the stream. We get an ID with all the parameters encoded, right? So it's unique at every time for different, like, based on all the input parameters. And then you have the stream, you have the session opened, right? And then when you want to close the channel as a teacher, your signature gets verified, and then you get the remaining, like both student and the teacher, depends on how much time has passed, they get the funds accordingly. And then so if this is a case where this withdraw function is called in case the teacher forgets to get their like claim their amount and close the channel, so then the student can get their state back. So we want to avoid basically locking in of funds. So
this is totally, and I'm assuming that most people on the call have seen this, but it's good to cover that get signer function does an EC recover, and that it probably just brings in the ECDSA. Nope, it's doing a full-on EC recover. So you can bring in the ECDSA stuff from OpenZeppelin and use their libraries, but this is one that I feel like this get signer I've copied and pasted into so many contracts that I use it all the time too. But it has this really cool superpower where you can see on line 137 through 139 that you within the smart contract, you give it a signature and you give it a message, and it gives you back who signed that message. And that's super powerful because being able to do signature recovering within Solidity like unlocks all sorts of cool scalability things.
Yeah, I think I'll just I think I pointed out, just want to point out, so there while testing, I think there were a few bugs with the remainder amount, right? Like the student with the UI and the contract as well. So where any negative case, there was an issue there. So now, as I mentioned, right? So in the a student does not need to do any additional transactions. So when you do a close, the student automatically gets the remaining part of the fund. So I think that was major update from a contract standpoint. Yeah.
Very cool build. Yeah, awesome work. So if someone wanted to, they could basically take this, what is it, MVPC, minimum viable payment channel. They could take your MVPC scaffold-eth build, and they could build out like, I mean, early versions of probably what Spank Chain is, or if they wanted to build out a mentorship session where it's like one to many, have a bunch of people sign in, put in their ETH, you do a live presentation and it streams to you, and then you can close those out. So there's a lot of powerful things that someone can take this branch off the shelf and use. So that's what I feel like that's what we're getting better and better with, making these really cool components within scaffold-eth. And this is a really powerful component. If you want to do off-chain signatures, like you need to do like micro payments, like you said, Viraz. It's a very micro payment-y feeling.
Yeah.
Like you would never be able to, send a couple of cents over Ethereum, but you can do that with signed transactions where you're signing just a few cents more and a few cents more and a few cents more, and none of those are going on chain until it needs to go on chain, and that last one goes on chain. Very cool stuff. Awesome work, Viraz and Saddam. And I think yeah, Iron Soul was in on this too, right? He's probably in bed. He's out partying. Awesome. Okay. Any questions? Let's open it up to the group. Maybe go, if you stop sharing your screen, we can go back to the gallery view, and we could, I can probably click that too. Cool. Yeah. Anybody have any questions? I think also if we have time, we should have Isaac show off the Rarible stuff, but any questions there on the payment channel?
I would have one. Is there a lockup period or anything? Like, or does it just go straight out of the box?
Yeah, so every channel, like every session has a duration till that point. Yeah, but there is no lot of restriction for the teacher. It's only mainly, right now for the student. So yeah, teacher can withdraw, any point of time within the session is active. Yeah.
Okay.
Is that a hash mask in the background, Soren? Do you have a hash mask printed out?
Yeah.
That's amazing.
Yeah.
That's leaked. Okay, Isaac, do you think you could give us a little? We'll have to hurry, but can you give us like a 5 or 10 minute speed run through your Rarible thing? Dope, awesome. Yep. A little bonus shill. Yeah.
All right. Can you guys see the?
We got it. Yep.
Excellent. So what I've done here, this is actually the default simple NFT example collection. I've changed absolutely nothing but deploying this to Ropsten. And I can show how we can actually sell these default things right on Rarible. For each of these NFTs, the first thing that we do is just approve the transfer proxy. The starter app is actually on Rarible's website now, docs.rarible.com under starter app. So scaffold-eth being represented there.
Amazing. Good work, dude.
Let me grab the NFT transfer proxy address.
And my hilarious art is now all over the place.
Yes. And let's do Flamingo in honor of, let's say, Flamingo DAO. So this first transaction approves the exchange to transfer stuff on our behalf. So I heard you mention signature-based order books earlier. So this is Rarible is a signature-based order book, kind of similar to Wyvern or how OpenSea works. So you get both sides of an order, and then anyone can call and match. Or if you just have your counterparty signature, you can make the transaction and match. So let's sell the Flamingo. Let's sell it for 0.1 ETH. And you'll notice that this is a signature. So we had another callback. Also mentioned the power of signatures. This is a signature of the entire order that we're approving. And this can all be verified on chain. So you can create a sell order without actually putting any data on chain and paying transaction fees.
And so that's sign type data too, right? That's to zoom in on that signature method. It's type data that you're signing, which is a little bit trickier, but I think we have a couple good examples for it.
Yep, it's typed and structured data. So I know this happened really fast, but we can already see that the Flamingo is on sale for 0.1 ETH. This is on Rarible's website. It's completely plugged in via the API. So Rarible is making a lot of effort to make their product not just like a closed Rarible site, but you can plug in absolutely any NFT. This isn't a custom one. This is the your collectible. So now let's go and fill that order. So I'm going to switch from account 1 to account 2. And let's grab our contract address. I like to keep the debug contracts just so I can always grab that. And the Rarible order indexer. So this pulls in, this will actually look on this the same way that Rarible knows that this flamingo is on sale. We can look it up here as well. So the collection address, I believe it's token ID 4. And a nice thing would be if I could like also pull in the image here. I just haven't done that yet. So we can see that token ID 4 is on sale for 0.1 ETH. I can fill that order, and that did not work. Let's see.
Is that's pinging their API?
Yeah.
The orders.
Let's see. Nothing to fill. Interesting. Promise I tested it beforehand. So let's try to sell this one. Let's try to sell this fish also for 0.1 ETH. Got a little live demos. All right, so I'm doing the reverse of this. So this address owns the fish, and I'm going to go ahead and try to buy it with my other account, and that is token ID 3.
It looked like some weird gas estimation stuff. Let's take that when the dialog comes up to look at gas limit for MetaMask. Let's look at that when you fill this order.
Actually, you know what? I just figured out. So I said it was token ID 4. It was actually token ID 5.
Okay.
It was an off by 1 error. So whenever MetaMask gives you a gas estimation error, it usually means that your contract is going to revert. In this case, it actually did give me actually let's pull up that error, because that's helpful for people to be able to debug that. Of course, it'll work this time, so that doesn't help.
Maybe do token ID 6 or something, right? That should cause it.
Let's see if token ID. There we go. We successfully got a failure. So let's look at this error. So this looks terrifying to someone that's just like, okay, what happened? But cannot estimate gas. Transaction may fail or may require manual gas limit. It almost never requires a manual gas limit. That's like a red herring. So the nice thing about Solidity errors, as of Solidity 0.5, I think, they added error strings. So MetaMask can actually tell us why, or it can actually tell us why this might fail. Reverted, nothing to fill. So the way that I would go and debug this is actually go into the Rarible smart contract repo and just do a control F on just like a regex searcher, look through the entire repo for the string nothing to fill, and find where in the Solidity code it says require condition, comma, nothing to fill. So that's how I would debug it. And let's pull up token ID 5 though.
But like you said, like nothing to fill is like a really big hint there that the thing that you're trying to buy is actually not there to be bought. Is that right?
I think that yeah, exactly. So when I was testing this before to make sure that everything went smoothly in my live demo, I filled an order, and that order still existed on the Rarible API. And that's what I went to fill again. So in this case, let's actually go ahead and fill our Flamingo purchase. And this is, you can see here, this looks very different from a signature. This is something where I'm actually spending 0.1 ETH to buy this thing. And my transaction has started. And hopefully, once that fills, using the nice hooks that Austin has built into scaffold-eth, this should just pop up on our interface when we bought it.
It's funny that Ropsten is the testnet of choice for Rarible, which Ropsten is great for testing UX because it's just going to be slow. It's proof of work, right? And it can get attacked. So it's going to be slow. It's not going to perform the way, like when you build something on Kovan and everything is every 5 seconds, your UI is built around that. You almost have to build an app with Ropsten to know how slow it's going to be when you get to the point of actually like having users use it and wait for transactions.
Ta-da. That filled. So the order filled, and we can see the Flamingo now on our Your Collectibles interface. So this was actually exchanged through the Rarible exchange. And if I click on the Flamingo, I can see that history. I can see that it was minted, listed for 0.1, and purchased. So you can use the starter app to start building your own application, but then all of the stuff plugs into Rarible's nicely built UI. One other thing I'll plug that you can do here is lazy mint. So lazy minting, all you have to do is give it the IPFS hash. And then the point of lazy minting is that you can create an item. It exists on the backend with a signature that says, I give someone else permission to mint this under the conditions that I specify. So this is a ways that creators don't have to pay that initial minting fee. And instead, the minting happens when the first person decides to buy it. So this is another typed data signature, which is saying that I give this contract permission to mint this token ID with this IPFS hash. So some people are scared of lazy minting, thinking that it's like editable or it's not decentralized. It's really just a precursor. It's like putting it in a pre-minting pool. So we've now minted this with this token ID, and that also exists on the Rarible indexer. Let's see how fast their indexer is. I think they've got some nice like, oh, let's see. I guess it's not fast enough. Oh, wait, that's a different, that is a different contract.
I'm assuming the lazy minting stuff isn't in any contract at all, or it's like one of their contracts that they probably have a special contract for all of their lazy minting. Is that right?
They do. You can also deploy your own.
Cool.
So let's see. Something about that URL doesn't look quite right. Oh, because it has to be. Bear with me 1 second. I'm just going to grab it. Because, yeah, as you were saying, this is using their already deployed contract. So I just want to grab that. And I'm editing the URL directly just because the way that it works on Rarible is that it's Rarible/token/contract address : token ID. So this is our lazy minted item. We can see that actually has never been minted. Even though it's never been minted, we can go ahead and sell it. Got our item. Let's sell it for 0.2 ETH. And can't read the domain. Okay, so live demos. But anyway, you can lazy mint the item, and you can create a sell order without actually going to without actually minting first. And then when you fill it, what it actually looks like on the interface is that it gets listed and then minted and then transferred.
So the minting happens at the moment someone purchases it. Is that right? Everything else is signature based until that moment.
Look how much data is packed in here. Like, this is a crazy long signature because it has to include all the signatures and permissions saying that you're both giving permission to mint and you're giving permission to sell. So we've created that sell order. Let's see if I can find a token ID. I want to add some nice caching so that this stuff stays in place.
Right. You've gotten this dangerously close where someone could, if someone wanted to build like a really smooth, lazy minting where someone just drags and drops the image in and it just creates the order in the indexer and then it like makes it, and then they ask them, how much do you want to sell it for? And they put the amount and then hit go. Like you could, and I like this where I have the debug contracts and the IPFS, but really someone could like take this, fork this, carve it down, make a really smooth, clean UI where it's just drag and drop, set your price, and you're done. And it's like basically you have all the functionality here. It would just take someone putting in the React.
Yeah, but, just got to do a bit more polish. And like this is that's kind of what we were hoping some people are doing at the Hack Money Hackathon. So we can actually see this went through. So we listed it for 0.1 ETH, and then it was minted, and then it was purchased. So this is how you know it's a lazy minted item. And you can see all that right here on the UI.
Fantastic. That's awesome. What a great starter kit. Anybody have any questions on the Rarible starter kit? Great work, Isaac.
Thanks.
I think like super cool that it's so open, like, and that anyone can like it's so like
I'm gonna start
composable.
using Rarible more. Yeah, exactly. So I can mint my own NFT on my own NFT contract with this and ship it to Rarible and have people bid on it. Like I can create an auction on Rarible with my own everything.
Yeah.
That's
Technically, you
amazing.
don't even have to. You don't even have to deploy. Like you don't even have to make your own front end marketplace. Like technically, you just use their website for any NFT contract. It's pretty crazy.
Which is how it should be. This is the composability of Ethereum, right? Like any NFT that you make anywhere should go everywhere else, but just people have not been great at building it that way. Awesome. Well, I'm going to check out Rarible more often. This is great. Thank you, Isaac, for presenting the Rarible. Thank you, Starter Kit. Thank you, Adam, for presenting the new deployment stuff. Thank you, Viraz and Saddam and ironsoul, who have pieced out, but it's late there, for creating the payment channel stuff. Great work. Happy Bowtie Friday. I'll see you guys in 2 weeks. Let's do this again in 2 weeks. See you guys.